Paideia 301, and we are continuing our class with our teaching of the Mumps language. So just follow up on a few things that happened last week. And I need to let you know basically that I had a couple of questions from Sue about things I did not. Oh, before we start, excuse me, I should make this clear to everybody. We're having a problem with our vForum system, and therefore what I'm doing right now is that I'm sharing my screen on Blue Button rather than through the through the forum system. And what's gonna happen is there's gonna be a little bit of a lag time since it's not quite as real time as the forum system, but hopefully it won't be too much and you'll be able to follow me. So okay, so what week is that Sue has asked me a couple of questions. A couple questions about stuff that I covered last week, and I wanted to recapitulate what they were. But before I do that, I'm going to just do a summary of our last class. So what happened last was the following. We recapitulation. Oh. So, Ted, I'll be trying to help you in a moment. So, what we said last class was that that Mumps had this structure, which is command argument, command argument, command argument. All right, that was the structure of Mumps. We also talked last week about strings and how variables look like strings without quotes. And then we talked about using a comma to repeat a command. We also talked about the look and feel of routines. Okay, Ted, I see that you say that that you keep crashing, and I don't think I can actually help you right now with the specific issue. I'm sorry. I'm not sure what's crashing your computer, so we can work on this later. Okay, so the two things that Sue asked me to clarify last time was the fact that I unwittingly abbreviated a lot of what I actually typed, and basically it's the command abbreviation. So let's look at what that looks like. So every command in Mumps basically can be abbreviated, and in most of VISTA you're going to see that the commands are indeed abbreviated. So for example, the write command has the abbreviation W. The read command, which we're going to see today, has the abbreviation R, and yes, thank you. I'm going to say, what's the third command that we already used? The set command has the abbreviation S. So in a typical Mumps like this one, you're going to notice the structure, the routine, and you're going to see a lot of I's and W's and D's and so on. And these basically mean W, right, S is for set, and the I, which you'll see a lot of at the top of this routine means if. And so we are this is basically a clarification, and I just wanted to make sure that everybody understood what it meant. When you write MUMPS code, you do not have to abbreviate, but what will happen is that you'll read far more MUMPS code than you write, and most of the MUMPS code in VISTA that you'll read is actually abbreviated. Okay, the other thing that Sue has asked me to clarify was what the definition of labels and what does it mean to have a label in a routine. So I'm scrolling upwards slowly, and I want you to see. Yes, Sue, that's absolutely right. I'm sorry. I know that you can't uh, uh, you can't copy and paste from this email you the capture. How about that? Okay. Do you hear me now, Sue? How about Doug? How about you? Do you hear me okay? Oh, sorry, Douglas is recording. Never mind. I don't want him to type. Douglas says for the most part. Okay. Manar says he's hearing me okay. So I'm hoping. All right. I'll try to talk slower. Oh, Sue says she could hear me okay now. All right. I'll try to talk slow. All right. So, what the thing that I want to show you today is Sue's other question was about labels. So, I have an example for you right now, and I want you to look at it very carefully. So, you will notice that almost every single line has a space before it. So, for example, this is a space, this is a space, this is a space, and this is something that's required in a MUMPS routine, that your first line either has a space or a tab before it begins. I know this is extremely unusual in a programming language, but that's the way it is. That's what MUMPS is. So a big question, what if you don't have a space? Well, if you don't have space, MUMPS will assume that what you have is a label. Examples of labels here, we have a label called XV up here. And then we have a label here called DZ. Oops, trying to highlight this thing. Here we go. And the purpose of labels in programs is that they are actually independently callable. So we don't have a lot of programs in this environment, but let me see. I think I have the program ZU. And this has a lot of, okay, good. Over here, there is a halt label, and there's a job exam label. I could highlight. So what you could actually do is, in order to run a routine, as we did last week, you do and then the routine name. So you could do this. Now I could type halt, which _ZU, which I'm not gonna do because this one actually will stop my process. So I'm not gonna do it. But I'm telling you, it's independently callable. You can also do job exam _ZU. So that is the main purpose of labels, and I'm going to leave it at that for now. Okay. So what I'm going now is we're going to start our new class today and continuing our next class. And what are we're going to cover? What we are going to cover today is we're going to discuss MUMPS data types. And when I talk about MUMPS data types, I want you to know that you probably will not understand what I'm saying. So this is something I'm going to repeat in the following classes. Then we are going to talk about using the basic commands set, read, and write. And then we're going to talk about the simple expressions that you could use in MUMPS. Okay, so let's start with talking about data types. Oh, Manohar is asking, is there a command to clear the screen? Yes, I did not want to type it, but since you're asking, it's write hash, which is a way to say form feed. If I type it, the screen is cleared. Okay. So, in MUMPS, let's talk about data types. MUMPS is very close to scripting languages, which basically means that if you use JavaScript, if you use Bash, it's very close to those languages in that basically everything is a single data type, and in MUMPS it's string. Unfortunately, I wish things were that simple. They're not that simple. Everything is indeed a string, but it's only a string when it's actually stored on your disk. The thing is, in the act of storing, it might change, and in the act of grabbing the data and applying operations on it, it also might change. So I'll give you an example. And by the way, I did mention already that if you don't understand this, that's okay. It's too hard. I know that this is very hard right now to understand, but I'm just going to mention it right now, and we're going to repeat it in the following classes. So, remember when I said write and we did hello world? So this is good. Okay, this is also good. So this is behaving as we expected. We wrote a string, we wrote a number. Look what happens when I do this. Not what we expected. Okay, another example. Here you go. I wonder whether this is gonna work. Oh yeah, here you go. So, in essence, what you're seeing here is the issue that even though we simply do tell everybody that MUMPS stores everything as strings, it's not actually as simple as that. In the act of storage, there's a transformation that happens. I could spell. That transformation is simple. If it looks like a number and it's not a string converted to a number. So what does that mean? And it's not a string. So if I do this, you notice that this is now a string. So when you actually write this out, you get this. But is it this simple? Let's try. Set x equal to 0002.000. Write x. Oh, actually, it works. So that's sort of behavior expected. So if you put it between quotes, it's now a string, and it's not a number anymore. But if you set x equal to 0002.000, write x, it's now 2. So essentially, this is the part, like a number, and it's not a string converted to a number. Oh, okay. All right. This is breaking up. Okay. All right. Do you guys still hear me? Okay. Let me see if I'm trying to figure out if there's anything that we could do to fix this. Okay, thank you, Douglas. So what I did, what I said, the thing that I said was, if it looks like a number and it's not a string, convert it to a number. So in the act of storing or getting your data from the user, MUMPS is going to say, okay, let me try. Does it look like a number? I'm going to convert it to a number. So this is what happened with x in this example, where it's 00002.000, and when I write it out, it gets converted to 2. But if you put it in quotes, then MUMPS is going to leave it as is and treat it like it is a string. Now, this is the first transformation that happens that alters the truism that we keep telling people that MUMPS stores everything as strings. The other thing that happens is that when you act on data, it does not become a string. It's not a string anymore. The way it's behaved. Okay, sorry, I'm breaking up. Okay, what I was saying is, based on how the data acts, based on the operations we apply to the data, something could be treated as a string, as a number, or a Boolean. So I'll give you a very simple example. Boolean. This last word, I'll write it down. Boolean. All right. So for example, this is the greater than sign. We've set in our math class. Is B greater than A? What do you think the answer is going to be? You could type in the chat. Okay, Linda says error. Thomas says 0. Manohar says 1. Okay, actually Thomas is right. It's not greater than A. You ask why? Well, This is the part where you're gonna have to understand mumps a little better. This is the whole point of me trying to explain this. B and A. Oh, Alice is asking, did you already assign value to B and A? Good question, Alice. Alice, let's go over what's the difference between a variable name and a string. Remember, I did up top. What I did is the following: is set x equal to 0002.00. Okay, let's try doing this. Set x equal to b. It's gonna tell you undefined local variable b. Now let me. I put b in quotes. Right, x. Okay. So what I just showed you over here is something we glanced at in the last class, which is variables look the same as strings, and if you do not put something in quotes, the language assumes it's variable. And this does not only work in mumps, it works across every single. I'm sorry, just a moment. Okay, sorry. No idea what is. Okay, I'm trying again. So what I'm saying is, basically in every language that I am aware of, probably with the exception of assembly, if you do not put quotes around something that looks like a string, it's assumed to be a variable. So, moving on. Oh, actually moving on and actually going back. Let's see. Okay. So, for Alice asked her question, we actually have. That's correct, Sue. That's exactly what I said. So, if I write A over here, it says it's an undefined local variable. If I so it's that A is a variable. If I write A with quotes, it's just the string A, and it writes it to the screen. Okay, so back to what we were discussing before on why this does not work. By the way, you might be wondering, this actually does work in other languages, but it does not work in mumps. So when we say B is greater than A, what happens is it's that other part that I told you about, that even though everything is a string, it doesn't actually work that way all the time. Everything is a string only when stored on disk. But now when you do the greater than sign, it tries to convert things to numbers and compares the numbers. We have not talked about the string to number conversion, and perhaps this is a good place to start. If a string does not begin with a number, it is assumed to be 0. So basically what write B greater than A means in reality, it's write 0 greater than 0. So it's really asking zero greater than 0. Now, and we know that 0 is not greater than 0. Okay. So the but the other thing that actually converts. Okay, Manohar is asking to please repeat. Okay, I will repeat it. You're okay. So Manohar, basically, if a string, if we are using the greater than sign, the greater than sign asks you to do a comparison between numbers, and therefore when it tries to convert the string B to a number and the string A to a number. String A and B, when converted to numbers, are both 0. So it's now really asking whether 0 is greater than 0. We are going to cover a lot more of this, but I just gave you one example. I'll give you another example. This one is going to be actually more surprising. Okay. Who wants to tell me expected result? Yes. Linda, I think, I don't know if you're okay with it. I think you might want to sign off from here and just watch me, because I think our bandwidth is too much for 2 people. Okay, we'll give it a try. Huh? I think there are some spots. Yeah, well, I think it's the fact that into our office we're getting a lot of stuff. Okay, so, all right, so I hope you guys will hear me better now, and Sue is going to just look at my screen rather than opening the screen herself. And I'm hoping that this actually helps our performance. So what I'm showing you here is the contains operator. Contains is a very simple it's a very simple way that you could actually test for the presence of something in a string. But contains is unique in that it actually converts both operands that you see to strings. So it's really asking, does the string 30122 contain 4? And the answer to that is what? Who wants to guess? 0? Okay. All right. That's all correct. Okay. So, okay, Sue's asking, 0 is no, right? Well, yes, Sue, that is indeed the case. What's the opposite of 0? Let's see if 30122 contains 3. It's 1. Okay. So, in the end, what's important for you to know is the following. And this is, I want to tell you again, I'm repeating myself again here. If it's hard, don't worry. It's expected to be hard. These things are sort of arbitrary. The language designers designed the language that way, and it's confusing, but you get used to it. So, you know, part of learning computer programming is sometimes endless frustration with trying to understand what the hell this thing is doing. So, the summary of what I'm telling you right now is the following. Mumps stores everything as string. The act of storage changes the data the data type for numbers. That's one thing. The operation changes, or the word we use in computer science is coerces. I don't know how to spell it. The data type per operation. The allowable. So Mumps data types are 1 string, 2 number, and 3 Boolean. Boolean means true or false. Represented, okay, that's good. Represented by 1 or 0. And if you guys know another language, the Boolean pretty much mirrors the way we do Boolean in the C language, which basically there is no real Boolean type, like there really isn't in Mumps. All you have to do is check if something is 1 or 0. And by the way, what if it's 2? What if it's 3? What if it is -5? It's all true. The only thing that's false is 0. Okay, so the next section that we're going to cover is we're going to talk about the basic commands some more. And I think we covered this a little bit last class, and I'm pretty much just reviewing it because you are going to need to use them in your homework. So let's start with doing set, read, and write. So we're gonna start with set. So basic commands. So let's do set. So set works like this. You say set variable equal something. So you say set variable equal 3. If you want to set multiple things, you set variable equal 3, variable 1 equal 3, variable 2 equal 4. And we said, as we said last class, a comma means repeat a command. And if you want to set something into a string, you say var 3 equal. Okay, that's all there is to set. How easy. Let's do write. So write is really simple. You do write and then variable name. If you want to repeat it, you do variable 1 comma variable 2. Now this is not exactly what we want. We see it says 34, which does not make any sense. So what I'm going to do is I'm going to write it this way. Write var 1. Now to add a new, you want to add a new line, and you do that using a basically an exclamation mark. It's shift 1, and that gives you a new line. Here you are. So now you have var 1, then a new line, then var 2. There's also another trick up sleeve. In order to format your output, you could tell it, move over, you could say question mark 30, for example. Alice, I'll answer your question in a moment. you can move over 30 and type in var1 and then exclamation mark, and you could say, and then var2. So what happens is mumps moves over 30 characters and then writes var1, then moves down a new line, then writes out var2. Okay, Alice's question. Can a variable or a string be set to more than one thing? The answer is most definitely not. You can never do that. If you set it to something different, it's changed for. Okay. This is the right command, and I just showed you one more thing actually, which was write £. Write pound, I'm not gonna run it because it's gonna delete the screen, but if you are executing this code on a screen, I'm gonna write it there. Okay. This basically clears a screen or on a printer starts a new page. You might be thinking, oh, VISTA has been talking to printer since the day it was born. So it's where you can actually connect to a printer. Okay, she says I'm breaking up again. So Linda is right, the sunspots. Okay, it's better. Okay, so what I'm saying is when you put a £sign and you connect to a printer directly, which you can do from the command line, you can actually just write directly to a printer, issue a new page. It's actually really fun when you connect to a printer and you start typing stuff on the command line, and then go ahead, close the device, and kaboom, you're actually writing directly to the printer. So this is a fun exercise for later. Won't cover it today. So the last thing I want to talk about as far as the basic commands is the read command. So read works like this. You just type read and then a variable. And then what happens is that basically mumps waits for you until you type something. Even nothing. So if you hit enter, I just entered nothing. If I write var1, it's empty. Let's try and read var1. I'm gonna put A, B, C, D, E, F. Write var1. Okay. That's good. That's an easy way. That's an easy way to actually read data. So this is something that's gonna come up, and the question is, I want to prompt the user to read in something, because I can't just type read and the user won't know what to type. So traditionally, what people would do is do something like this: write hello there, enter your name, colon, and then they would type read name, and then I would type my name. Okay, but the read command actually gives you a shortcut to do this. The read command allows you to type a string and then you put a comma and then say name, and then just hit enter. So it actually prompts you now, and asks you, enter your name. And this is a useful shortcut to have. Here you go. Okay. So, little pause here. I want to know if any of you have any questions about what we covered so far. Can you please type it in the chat if you have any questions? All right. Are you setting a Alice asks, are you setting a variable when you type your name? Yes, Alice, I am actually, because the read, if I typed read of X, if I type read of X, what's going to happen is I have to type something, and now if I write X, X is set that to that value. Read actually, what read does is it basically, I think I actually failed at explaining what read. Sorry about that. Read gets user input. Okay, sorry, and solar sunspots. Okay, I'll try again. What read does is that it takes the user input and puts it into a variable of your choosing. So this statement which I ran up here, read hello there, enter your name, and then comma name. This essentially, when I execute it, it takes my input, whatever it is, and puts it into the variable name. So if I write name, I get this. Does that make sense? Okay, thanks. Okay, so Sue asks, I don't see where you set the variable. I did not explicitly set it, Sue. I said read a string, comma, a variable name. So what it is going to do is going to print out the string first, then it's going to take your it's going to take the user input. So how did it know to use Sam? I don't think I used Sam. I used the variable name. So let's try it again, Sue. So read, enter a number, colon, X. Okay, when in your case that you mentioned in the chat, Sue, it's basically what I actually typed into the screen. So here's another example. I hope this would make it easier. I type 3.2 and then hit enter. Then I write X, and X is 3.2. Does that clarify it? Okay. Okay, good, good. So read essentially takes an input from the user into a variable of your own specification. So here's another thing to do with read that might be confusing, but it's also valid. Nobody does it, but it's allowed by the rules of MUMPS. You could say read X, comma Y. So what do you think will happen? Who wants to guess on the chat? I read X, comma Y. Yep, that's correct. You're going to ask for two variables. You're going to enter a number called X. I'm going to hit enter, and guess what? It looks like as if nothing happened on the screen, but it's really asking for another variable. So you're gonna hit something else. So it's confusing, but what really happens? Write x, x is 3, write y, y is 7. Put an enter between the 3 and the 7. Okay. So the next thing I'm going to cover now is numeric expressions, and these are actually pretty easy because most of them are very easy to understand. So I'm just gonna go over them very quickly. They won't take time. We're gonna start with the plus sign. The plus sign adds, so you have to type write 3 plus 4. That is 7. If you write 3.33 plus 4, it gives you 7.33. Okay, I'm breaking again, sorry. Okay, so if do if the decimal base, that addition happens. So that's pretty straightforward. Calculator. Oh, Sue says nothing. Breaking up. Sorry. Okay. Wait a moment. Yeah. I'm sorry about today's quote-unquote technical difficulties. It's now a term of derision, but hopefully next time we'll have better luck. Do you guys hear me now? Okay, good. So the plus sign acts the way that you expect. And as you expect, if you write hello plus world, who wants to tell me what this is going to be? Okay. Wow. This is all over the place. Oh, wow. So, here, this is the part that's pretty interesting. In mumps, the plus never acts as concat. It's more like your what shall we say? I don't know. It doesn't act like any language I know right now. Essentially, what you're getting here is that it's coercing both things into a number, and so hello converted to a number is 0, and world converted to a number is also 0, and therefore, guess what? 0 plus 0 is 0. So, in order to get hello world, like several of you actually wanted, there's a separate concatenation operator in mumps. The concatenation operator, which we're going to cover in more detail later, is an underscore. That will give you a hello world. An underscore is concatenation. So, by the way, who wants to tell me what the result of this is going to be? Anybody? It should be easy. All right. Yep. That's right. It's a concatenation strings things together, and guess what? It converts its arguments into strings. Okay, so that was easy. Now we know how plus behaves. A very common operation in computer programming is incrementing. So in MUMPS, there is no such thing as x plus plus, for example, to increment x, or plus equal x. Now, if you don't understand what these things are, don't worry about it, because these just don't exist in MUMPS. In MUMPS, incrementing works like this. Set x equal to 1 and set x equal to x, and that's how you increment. Okay, I'm breaking up again. Let's wait a moment. Okay. Sue, do you hear me okay right now? Okay, I'll repeat. What I was saying is that in MUMPS, when you increment, basically say, set the variable equal the variable plus 1. And that's all there is to it. So now you write x and it's 2. If we run it again and we write x, it's 3. Okay, the next thing I'm going to cover is minus. A minus is decrement. A minus, excuse me, a minus is subtraction. What am I thinking? Okay, so this is easy. Write 3 minus 4 will give you negative 1. Write 10 minus 7 will give you 3, and so on. So there's nothing complex about this. And again, with strings, here's what happens. Hello minus world is going to give you, all right, how about you guys guess? 0, okay? That's good, because it's, and here you are. And as with addition, decrementing is done the same way. So if we write x, it's 3. So set x equal x minus 1. And write x. X is now 2. We run it again. X is now 1. Okay, so the next operator we're going to cover is the following. Multiplication. A star, like in just about every programming language I know, multiplication. So star is multiplication. And this is really simple. So write 3 times 4, and here you are. That's pretty straightforward. So, say, now this is the slant or the slash, this is division. And that's also pretty straightforward. So if you write 9 divided by, let's make it 12 divided by 3, it will give you 4. Four divided by 3, that's an interesting one. This one is a bit difficult to predict because different languages behave differently. But in mumps, whenever you do division, you always do just division like the calculator does it. So it's really easy. There's nothing to think about. It actually does what your calculator would do, and that's all there is to it. Now, what if you want the special? Alice asked a good question. Is there a limit to decimal places? Alice, there is, but I don't remember what it is. It's set down in the MUMPS 95 standard, and I don't remember what it is. I can actually let me see. I don't know if I have it in my old, but I used to have it. Not sure. I do remember that I do remember that there's a limit, so I'm gonna have to get back to you on that one. But for practical matters, Alice, sorry, I'm breaking again. Okay, so you hear me now? Okay, do you hear me now? Okay, good. So, Alice, as a practical matter, you never reach the decimal places in medicine that you actually run out of language. In general, we try to use as many decimal places as we can, especially in metric to metric to English conversions or vice versa. But usually you want to have an extra decimal place in any conversion. So this is actually a good topic for actually, that other languages have keywords to protect you against loss of accuracy, but that doesn't exist in MUMPS. So in that regard, it's pretty simple. So back to the other operators. There is something called integer division, and this is using a backslash. Do you hear me okay now, Manosh? Okay, good. I'm going to try to end the class early today because we're having problems, but I'm going to give you enough information to go on to be able to do your homework. Okay, so integer division is simple. I cannot really explain it until you actually see this. Okay. So basically, integer division strips out everything, all the decimals out of your division. So 6 integer division over 3 gives you 2. 7 over 3 will also give you 2. There's a side effect of integer division, and that is you can use it to strip off any number just by integer dividing 1. You could strip off the decimals. So you could write 7.777 integer division 1. It will just give you 7. Okay, so the next one is called a modulus. If you guys are familiar with other programming languages, okay, just a moment. Sue asks, does it round up or down? Sue, it does not round, it strips. It strips, which means that uh, any number dot any number, yes, exactly. 2.9 and 2.3 are both going to be 2. Okay, so the next command is the modulus, and the modulus works like this. Modulus in most other languages is not a hash, but it is in MUMPS. And modulus is simple. Again, easier to illustrate. So write 4 modulus 3, give you 1. So if you remember integer division, which you did back in, middle school, that's the sort of thing that you did. You divided something and you got the remainder. So what the modulus is, it's remainder. So, oh, okay, I'm breaking again. Better now, Sue? Nothing after, okay. All right, do you hear me now? Nope. Oh my, it's really bad today. Okay. Okay, so modulus is what you learned about in middle school when you did integer division, and basically it's you get when you divide something. Oh yeah, that's you, Douglas. It's called the modulo as well. When you divide something, you get something called quotient, and the besides the quotient we get I get something. I actually get the remainder, and the remainder is what the modulus is. So another example: 8 modulus 3. What's the remainder of 8 and 3 divided by 3? Who wants to guess? Okay, 2 is correct. And that's what we get. This is useful in all sorts of problems. And one simple thing that actually you usually see a lot is if a number is modulus 2. Okay, do you hear me now, Sue? Okay, good. So 8 modulus 2 is 0, and it means it's even. But 9 is odd, and you're going to get a 1. So modulus 2 always means, is it even or is it odd? And you actually see that a lot in VISTA because of a property of mumps of a mumps command that we're going to deal with in a future class. But again, we're not going to talk about it today. The last arithmetic command that I'm going to show you is the exponentiation command. And exponentiation command in MUMPS is the same as in all the C languages, and it's basically 2 asterisks. So 3 exponentiated to 3 will give you 27, and 3 exponentiated to 4 will give you 81. And there is, extra credit. I press insert. What is this going to give me? Anybody? Nope. Now, 9 to the, nope, no. Okay. This is something you might have learned about in algebra back in the day. Exponentiating by 0.5 means taking the square root of something. So 9, the square root of 9 is 3. That's an easy way to do a square root in VISTA. And are there reasons to do square root in VISTA? You bet, there are. Especially when you're writing lab tests, because these involve a lot of math. Okay, the last few commands, and that's going to be the end of the class after this, are the following. So the first command I want you to we actually talked about it a little, is less than command. So is 9 than 3? Type your answer. Sorry. Breaking again. Sorry. Hear me okay now? You're still getting okay. Okay, do you hear me now? Okay, you can now hear me. Okay, so my question was, what's 9 less than 3? Why don't you guys type your answers in? Okay, 0 is correct actually. 9 isn't less than 3, so you get true or false. So essentially what you're seeing now is that the result is going to be either 1 or 0 or 1 for this operator. Now, in most other languages, you can also type this is 9 less than or equal to 3. And all those people who've been saying we're going to get an error, you're going to get your wish fulfilled now. Yes, we do really have an error here. So, how in the world are we actually going to do less than or equal? Well, this is one of the things about mumps that's not that great. You basically have to negate the operation. And the way you negate an operation in mumps is the following. It's you say not greater than, which means less than or equal. So this is less than or equal. Okay. And opposite of this is also true. So write 9 greater than 3 and write 9 greater than or equal to 3. Is that reverse notation confusing? You bet. I really do get confused about it every time I see it. And every single time I actually have to look and see whether I am thinking correctly or not. By the way, cache does allow for less than or equal, but it's not part of mumps, and some VA code that slips through and does not get corrected, and so you need to be careful that basically when you're running on GTM, you need to actually check and make sure that that you write it the correct way. Okay, the last thing I'm teaching is the equals, right? The equal is easy. Is 9 equal 9? Yeah, you bet, yeah. Is 0.2200 equal 0.22? Yes, sure it is. Equal is very simple. The only thing that's confusing for anybody coming from any other language is the fact that there's only a single equal sign, which makes life a bit hard if you write in several programming languages. Most programming languages I'm aware of use double equal signs to perform equality. But MUMPS is very much a context-based language, so when you say this equals this, it actually does an equality check. If you use the set, so let's actually set another example. Let's x equal to. Can you write not equal? Yes, Thomas, you can write not equal. Thank you very much. Here we go. Here's x. So if I write x equals to 0.33, I get 0, because essentially it's doing a comparison. But if I say set x equal 0.33, the equal sign is a totally different right now. And as Thomas said, can we write not equals? We sure can. I'm going to write it right now. So x not equals to 0.33. And that gets us the number 0, because x is 0.33. Okay, so you can tell the difference. Let me see. I'm trying to see if there's a way to explain it. Okay, I will try to explain it this way. Unless you have a set in MUMPS, the equals is always comparing. The only time equals is for assignment is when you are actually using the set command. Does that help make it easier? I'm not hearing back from Sue. Oh, okay. Tell me the assumption again. Okay. In MUMPS, that you only use a single equal sign, both for setting and for comparing. But the only time where it's used to set is with the set command. That's the only time where the equal is actually setting a value. In all other instances, the equals does a comparison. All right. Oh, Alice, oh my God, I forgot to mention this. Oh my, thank you for asking. I totally forgot. I was almost going to gloss over it, but okay. What Alice is alluding to is actually a very major problem in MUMPS, and I've asked George Timpson about it, who is the writer of FileMan, and we sort of agree it's one of MUMPS's very worst features, and that is basically MUMPS does not take precedence, and the reason it doesn't do that is that Neil Pappalardo, the person who designed the language, thought that not doing precedence is going to save you computing cycles. We now know that that's not really true. But so let's take Alice's example, but let's simplify. So 3 plus 4 times 2. Now, if we actually did precedence, what's going to happen is It's going to be 4 times 2 is going to get executed first. It's going to be 8, and then we add 3 and we get 11. But that's not what you're going to get here. You're going to get 14. So mumps operates in a strict right to left order. Is it right to left or left to right? Let me see. No, left to right. Sorry, I can't get my directions. By the way, if you're ever in a car with me, you should know. You should point rather than tell me left or right, because I don't have a clue which direction I should go. Okay, Thomas wants to stretch the thing, so set x not equal to 2. Here you go. Okay, so the press things, and thank you, Alice, so much for bringing it up. I remember to bring it up. The precedence is really a pain in the ass and oh, sorry. Well. Okay, so there's nothing now. Let's see. Okay, do you hear me now? Okay, good. So, the precedence thing is a big pain in the ass in mumps. It really is, because you don't see it right now, because you think how big of a deal this is. It's a big deal because essentially when you're doing parentheses, yes, you can do parentheses, Alice, thank you. But essentially it gives you very weird, it essentially means that you have to type things in a very weird format. And the weird format is as follows. The weird format is you have to type if x equal to, or then you have to do a parentheses. And we're not, I actually won't bore you with what this means right now. This is not for today. But typically in mumps, your first condition does not have parentheses around it, but then it starts evaluating from left to right. So if you omit the parentheses, what happens is it's going to say is equal to first, then what it does is that or 2, and then it says, oh yeah, it's 2, okay, fine, I'm done. No, we don't want it to do that. We actually want to say or 2 times 2. Okay, I guess I actually mentioned or briefly, but we're going to discuss ands and ors time. So we're not discussing ands and ors today. So okay, so Sue is asking, does this work? 3 plus 4 times 2. The answer is yes. But in reality, what we want, this is the default behavior. So what we really want is 4 times 2 to run first. What is the X meant? The X phrase that I typed basically says if X equals to 2 or 4. It's nonsensical, so it doesn't mean anything. It's a bad example, sorry. Okay, so for our homework for this time is going to be the following. So I just need to copy and paste it because I had it in my notes from a class I gave earlier. Nope, that's not gonna work. Okay, just a moment, folks. Okay. Okay, so you basically 3 separate routines that you need to write for this class's homeworks, and you have 2 weeks until next class to do this. So the way it's going to work is you're going to create a routine which calculates the circumference of a circle whose radius is 12.5, just like that, exactly like that. Then you're going to read the radius from the user and then calculate the circumference. So the first homework, you're going to create a routine where everything is hard-coded and you're only going to use a statement. The second routine, you're going to use the read statement to read it from the user, and then you're going to use the write statement. Third routine, you're going to read the input from the user and then test it with a less than sign. Okay. So Menage says, "Can you please send the email from the homework?" I'm going to send the whole screen scrape from today as in a text file attached to an email, Menage. Okay, thank you. And and Sue and Linda, excuse me, Linda is actually typing the homework into an email right now, and she is gonna send it to you. So that's good. Sue, I'm sorry. Okay. Okay, Alice is asking, any chance you could quickly show how to build a routine in VPE? Yes, Alice, I can certainly show you how to do that. Okay, Linda just sent the homework on the list, so that's good. So, the VPE in this environment, you're gonna execute up caret %x. Okay, so when you run up caret %xves, you're gonna get asked this question. Right now, you're gonna get to use number 1 as a default. And then to edit the routine, you type .e, and then you type the routine name. I'm gonna use my next page, which is Z0, and I'm gonna say, let's just call it RTN1. So the first thing you have to do is you have to hit enter, like this. So you just hit enter, and now you actually get to type your first line. The first line should always look like this. Should be the routine name, and then you press tab, and once you press tab, the routine name becomes a label, and then you put a semicolon, and then you type the organization you work for, then your initials, then a dash, then the purpose of the routine. And then you hit enter. If you're not going to put any label, you just press tab and you type in what you want to type. So the third line, I'm going to do a label. So I'm going to type the label first, and then I'm going to press tab, and now I have the label. Then the next line, I'm not going to have any label, so I'm going to do write hello world and an exclamation mark for a new line. And I suppose I should have taught you, but just take it from me now, just put it at the end of your routine. And press escape twice, and you hit enter. Now to run it, you type do upgrade Z00RTN1, and here you are. I hope this helps. Can you give us a picture of that in email? I could not capture it. Sue, this is going to be a bit difficult. We're going to probably have to do a step-by-step guide, and I'm basically going to be busy for the next week, so I'll see what we could do before next time to give you. Yes, Linda did send out a VPE guide. But does it? I've not read it. Does it contain step-by-step of to edit a routine? Oh yeah. Okay. You did send an email. Okay, Linda will find it and resend it. Okay. That's it. Manohar is asking, do we have a session on next Tuesday? The answer is no, we do not have a session on next Tuesday. Our next session is going to be a week and a half, 2 weeks from today. So you have 2 weeks to do your homework. Next week, I will be on plane to New York, actually New York to Washington. And there's the Osera conference going on, which is it's a VISTA organization. There's a conference going on. So if you are going to be there, I would like to see you, whoever you are. Okay, that's it for today's class, and I apologize for the problems we're having. Hopefully, we could go back to our low bandwidth solution that we were using before, sharing a screen session. I just found out before this class started that I couldn't access it. So hopefully by next week we'll have it straightened out. A week after next, excuse me. Okay, that's it. Thank you, folks, and I'll make sure to send this to you.